Flight instruments are the instruments in the cockpit of an aircraft that provide the pilot with information about the flight situation of that aircraft, such as altitude, airspeed and direction. They improve safety by allowing the pilot to fly the aircraft in level flight, and make turns without a reference outside the aircraft such as the horizon. Visual flight rules require an airspeed indicator, an altimeter, and a compass or other suitable magnetic direction indicator. Instrument flight rules additionally require a gyroscopic pitch bank, direction and rate of turn indicator, plus a slip skid indicator, adjustable altimeter, and a clock. Flight into instrument meteorological conditions require radio navigation instruments for precise takeoffs and landings. The term is sometimes used loosely as a synonym for cockpit instruments as a whole, in which context it can include engine instruments, navigational and communication equipment. Many modern aircraft have electronic flight instrument systems. Most regulated aircraft have these flight instruments as dictated by the U.S. Code of Federal Regulations, Title 14, Part 91. They are grouped according to pitot static system, compass systems, and gyroscopic instruments. Pitot static systems. Altimeter. The altimeter shows the aircraft's altitude above sea level by measuring the difference between the pressure in a stack of aneroid capsules inside the altimeter and the atmospheric pressure obtained through the static system. It is adjustable for local barometric pressure, which must be set correctly to obtain accurate altitude readings. As the aircraft ascends, the capsules expand and the static pressure drops, causing the altimeter to indicate a higher altitude. The opposite effect occurs when descending. With the advancement in aviation and increased altitude ceiling, the altimeter dial had to be altered for use both at higher and lower altitudes. Hence, when the needles were indicating lower altitudes, i.e., the first 360-degree operation of the pointers was delineated by the appearance of a small window with oblique lines warning the pilot that he/she is nearer to the ground. This modification was introduced in the early 60s after the recurrence of air accidents caused by the confusion in the pilot's mind. At higher altitudes, the window will disappear. Airspeed indicator. The airspeed indicator shows the aircraft's speed relative to the surrounding air. It works by measuring the ram air pressure in the aircraft's pitot tube relative to the ambient static pressure. The indicated airspeed must be corrected for non-standard pressure and temperature in order to obtain the true airspeed. The instrument is color-coded to indicate important airspeeds such as the stall speed, never exceed airspeed, or safe flap operation speeds. Vertical speed indicator. The VSI senses changing air pressure, and displays that information to the pilot as a rate of climb or descent in feet per minute, meters per second or knots. Compass systems. Magnetic compass. The compass shows the aircraft's heading relative to magnetic north. Errors include variation, or the difference between magnetic and true direction, and deviation, caused by the electrical wiring in the aircraft, which requires a compass correction card. Additionally, the compass is subject to dip errors. While reliable in steady level flight, it can give confusing indications when turning, climbing, descending, or accelerating due to the inclination of the Earth's magnetic field. For this reason, the heading indicator is also used for aircraft operation, but periodically calibrated against the compass. Gyroscopic systems. Attitude indicators. The attitude indicator shows the aircraft's relation to the horizon. From this, the pilot can tell whether the wings are level and if the aircraft nose is pointing above or below the horizon. This is a primary instrument for instrument flight and is also useful in conditions of poor visibility. Pilots are trained to use other instruments in combination should this instrument or its power fail. Heading indicators. The heading indicator displays the aircraft's heading with respect to magnetic north when set with a compass. Bearing friction causes drift errors from precession, which must be periodically corrected by calibrating the instrument to the magnetic compass. In many advanced aircraft, the heading indicator is replaced by a horizontal situation indicator which provides the same heading information, but also assists with navigation. Turn indicators. These include the turn and slip indicator and the turn coordinator, which indicate rotation about the longitudinal axis. They include an inclinometer to indicate if the aircraft is in coordinated flight, or in a slip or skid. Additional marks indicate a standard rate turn. Flight director systems. These include the horizontal situation indicator and attitude director indicator. The HSI combines the magnetic compass with navigation signals and a glide slope. The navigation information comes from a VOR, localizer, or GPS. The RD is an attitude indicator with computer-driven steering bars, a task reliever during instrument flight. Navigational systems. Very high-frequency omnidirectional range. The VOR indicator instrument includes a course deviation indicator, omnibearing selector, to/from indicator, and flags. The CDI shows an aircraft's lateral position in relation to a selected radial track. It is used for orientation, tracking to or from a station, and course interception. Non-directional radio beacon. The automatic direction finder indicator instrument can be a fixed card, movable card, or a radio magnetic indicator. An RMI is remotely coupled to a gyro compass so that it automatically rotates the azimuth card to represent aircraft heading. While simple ADF displays may have only one needle, a typical RMI has two, coupled to different ADF receivers, allowing for position fixing using one instrument. Layout. Most aircraft are equipped with a standard set of flight instruments which give the pilot information about the aircraft's attitude, airspeed, and altitude. T arrangement. Most aircraft built since about 1953 have four of the flight instruments located in a standardized pattern called the T arrangement. The attitude indicator is in the top center, airspeed to the left, altimeter to the right, and heading indicator under the attitude indicator. The other two, turn coordinator and vertical speed, are usually found under the airspeed and altimeter, but are given more latitude in placement. The magnetic compass will be above the instrument panel, often on the windscreen center post. In newer aircraft with glass cockpit instruments, the layout of the displays conform to the basic T arrangement. Early history. In 1929, Jimmy Doolittle became the first pilot to take off, fly and land an airplane using instruments alone, without a view outside the cockpit. In 1937, the British Royal Air Force chose a set of 6 essential flight instruments which would remain the standard panel used for flying in instrument meteorological conditions for the next 20 years. They were altimeter, airspeed indicator, turn and bank indicator, vertical speed indicator, artificial horizon, directional gyro, heading indicator. This panel arrangement was incorporated into every RAF aircraft, from the light single-engine Tiger Moth trainer to the 4-engined Avro Lancaster heavy bomber, and minimized the type conversion difficulties associated with blind flying, since a pilot trained on one aircraft could quickly become accustomed to any other if the instruments were identical. This basic 6-set, also known as a 6-pack, was also adopted by commercial aviation. After the Second World War, the arrangement was changed to airspeed, artificial horizon, altimeter, turn and bank indicator, heading indicator, vertical speed. Further development of the old basic 6 instruments, the turn and bank indicator, is now obsolete. The instrument was included, but it was of little use in the first generation of jet airliners. It was removed from many aircraft prior to glass cockpits becoming available, with an improved artificial horizon, including gyros and flight directors. The turn and bank indicator became needless except when performing certain types of aerobatics. But the other 5 flight instruments, sometimes known as the Big Five, are still included in all cockpits. The way of displaying them has changed over time, though. In glass cockpits, the flight instruments are shown on monitors. but the display is not shown by numbers, but as images of analog instruments. The artificial horizon is given a central place in the monitor, with a heading indicated just below. The indicated airspeed, altimeter, and vertical speed indicator are displayed as columns with the indicated airspeed and altitude to the right of the horizon, and the vertical speed to the left in the same pattern as in most older-style clock cockpits. Different significance and some other instrumentation. However, all 5 instruments are not equally important. Only the artificial horizon, altimeter, airspeed indicator and compass are imperative. Due to this, all passenger airliners are equipped with a battery-powered integrated standby instrument system, along with a magnetic compass. The vertical speed indicator, or VSI, is more of a good help than absolutely essential. On jet aircraft it displays the vertical speed in thousands of feet per minute, usually in the range -6 to +6. The gyrocompass can be used for navigation, but it is indeed a flight instrument as well. It is needed to control the adjustment of the heading, to be the same as the heading of the landing runway. Indicated airspeed, or IAS, is the second most important instrument, and indicates the airspeed very accurately in the range of 45 to 250 knots. At higher altitude, a Mach meter is used instead, to prevent the aircraft from overspeed. An instrument called True Airspeed, or TAS, exists on some aircraft. TAS shows airspeed in knots in the range from 200 knots and higher. The altimeter displays the altitude in feet, but must be corrected to local air pressure at the landing airport. The altimeter may be adjusted to show an altitude of 0 feet on the runway, but far more common is to adjust the altimeter to show the actual altitude when the aircraft has landed. In the latter case, pilots must keep the runway elevation in mind. However, a radio altimeter has been standard for decades. This instrument is, however, not among the Big Five, but must still be considered as a flight instrument.